In this section, we're going to look at the development and layout of the modern periodic table. In the late 1860s, there were approximately 60 known elements, with additional elements being regularly discovered and their properties explored. A Russian scientist, Dmitry Mendeleev, organized the known elements into a table based on their atomic masses and their properties. He put compounds with similar properties, such as chlorine, bromine, and iodine, into columns. By doing so, he was able to predict the existence of several elements, such as germanium and gallium, that hadn't even been discovered yet. As time went by, additional elements were discovered and named, leading to what we call the modern periodic table. The term periodic means cyclical and indicates how a periodic table is organized. You're probably used to using a different periodic table, a calendar. In a calendar, each horizontal row takes you across a week, which covers a spectrum of activity. For example, on Sundays, I usually go to church and then enjoy a quiet evening. A lot of times I like to watch a ball game or just hang out and drink coffee with the family. On Monday, I go to work, continue to work on Tuesday, Wednesday. Sometimes there's special things that happen during the week. There might be a lab I need to be in or a report that's due every Thursday. Friday I work, and then a lot of times Friday night might be a movie night. On Saturday, I tend to be at home, work around the house, do chores, fix what needs to be fixed, or take kids to their activities. I've covered an entire spectrum of activity. And then the next week it starts again. Sunday morning, go to church, watch a ball game, drink some coffee. Monday, go to work. And it's going to repeat in this sort of way. And you're very familiar with this pattern. Things in general, week to week is not exactly the same, but it does tend to be a lot the same. So we can say that as we go across the calendar, we go from one end of the spectrum to the other. We go all the way through the week. However, as we go down a calendar, things tend to look pretty much the same down each column. The periodic table is organized in much the same way. As you go across the periodic table, you cover the entire range of properties. Starting on the left-hand side, you encounter atoms which are more metallic in their character. As you move to the right, they become less metallic. The compounds across the middle are often referred to as the transition metals. Heading further into the right, you head into what are called the metalloids, and then into the nonmetals. And finally, you reach the column at the far right, the blue column we refer to as the noble gases. Now, as we'll see as we continue our study, this pattern can be tied to electronic behavior, but for now, we can tell what anything is going to do by where it falls on the periodic table. For example, we know that potassium is a metal because it's on the left-hand side of the periodic table. We know that potassium is going to behave a lot like sodium, a lot like lithium, because it falls into the same column as those other atoms. If we wanted to ask a question like which atom would behave most like oxygen, probably our best answer would be sulfur, the one right next to it and in the same column on the periodic table. Periodic tables may contain more information about each atom, but there are three key components which are nearly always present. First, we have the symbol. This is a 1 or 2 letter symbol that tells us what the atom is. At the top of the periodic table, there's a number. This is called the atomic number. The atomic number gives us the number of protons in the nucleus. It also gives us the number of electrons in a neutral atom. Listed on the bottom, we often see what we call the average atomic mass. This is the average mass of that particular type of atom. These three things are going to be there almost every time, and we'll talk about how to use each one as we go through subsequent sections. Finally, we use a calendar to help us remember key events and ideas. We don't have to memorize everything on the calendar. We're able to see at a glance what's coming up. In the same way, the periodic table of the elements is a tremendously handy reference guide. As you gain experience, you should be able to tell at a glance many of the key properties of the elements. We'll explore this in more detail in later sections.